Thank you for joining me at CodeRage 9 for my session on creating highly connected apps with Bluetooth and Kinvey using RadStudio XE7. My name is Sarina Dupont, and I'm a Senior Product Manager at Embarcadero Technologies. I'm also joined by Caroline Murphy, Director of Client Services at Kinvey. Now let's talk a little bit more about building connected applications with RadStudio XE7. The way that we experience and interact with devices is really changing, and we make it very easy for developers to build mobile and desktop applications that connect to devices, sensors, services, data, etc. very easily. With RadStudio XE7, you can build connected applications for many different industries, such as point of sale, food services, healthcare, manufacturing, and shipping, and the applications are really limitless that you can build. The way that we enable you to build connected applications is through a variety of different technologies that we provide with our solution. For example, one of them is app tethering that allows you to easily extend a desktop application to a mobile application or control a desktop application with a mobile application using either Bluetooth or Wi-Fi. We also have support for Bluetooth smart devices via Bluetooth LE support. We have built-in components for accessing REST APIs. So for example, you could connect to a fitness device that has a REST API to retrieve its fitness data, for example, your daily steps, as well as using the SDKs that are available for specific devices to then build connected applications. You can also support many different devices with the same code. So for example, if you're targeting a Bluetooth LE smart device, such as a heart rate sensor, you can write your application once and have it work with various heart rate sensors by various manufacturers that subscribe to that same GATT profile. Now let's talk a little bit more about our BaaS integration in RadStudio XE7. Our BaaS integration allows you to access data and object storage in the cloud. We also provide support for user authentication. So for example, the user can easily log into their application. You can build in support for signing up a user, providing a password reset functionality right within the application, or triggering a password reset email, allowing the user to upload files to the cloud, also consume data that they've added either manually via the BaaS web interface or through their application. It also supports push notifications, and we have built-in support for Kinvey as your BaaS provider. And with that, I'm going to pass the mic to Caroline Murphy from Kinvey.
Thanks, Sarina. Hi, everyone. I'm Caroline Murphy. I'm Client Services Director at Kinvey. And I'm going to take a quick second to explain what Backend as a Service is and how it helps you when it comes to building mobile applications. So the term Backend as a Service just means that we package up a lot of functionality that you would want in your application and provide it as a service. For example, the app that we're building uses features like authentication, data storage, business logic, and push notifications, which are just a few of the features that you get with a Backend as a Service. So as we go along here, Sarina is going to explain what parts of the app are using Kinvey components so that you can get a better picture. Embarcadero has actually built in Kinvey components to the platform to make it even easier to use, which is what we're going to cover. So the other benefits of using a Backend as a Service instead of building your own backend are that you save significant time developing, you get the added benefits of scalability, and you don't have to worry as much about backend maintenance. That's our job. We do that instead. Okay, I'm going to pass the mic back to Sarina now.
Thank you, Caroline. Now let's talk about how you can integrate and use Kinvey with RadStudio XE7. Now the first step is to create your Kinvey BaaS backend, and you would sign up for an account by going to kinvey.com, and then you sign up with your information, and the next step is to create a new app backend. In that case, you would select REST API and click Create App. And then once you have created your backend, you're provided with an app ID, an app secret, and a master secret. And in our product, we have a Kinvey provider component that you can drag and drop right onto your form. And then you put the app ID, app secret, and master secret that is provided to you via your Kinvey dashboard into that component, into the fields that the component provides. And you can then connect that Kinvey provider component to various other BaaS components that we provide out of the box. So for example, push events, push backend storage, backend push, BackendQuery, etc. So we have many different BaaS components that connect to that Kinvey provider component to provide you out-of-the-box built-in support. So let's talk about what we're going to demo today. We're going to show how to add cloud-based user authentication to your application and how to connect to a Bluetooth LE heart rate monitor, how to then take that data you're receiving from the heart rate monitor and store it in the cloud. After it gets stored, you were also going to query that existing data that lives in the cloud and display it on a chart that gets updated every second to show the current heart rate data as well as the historical heart rate data. And then we're also going to send a push notification to the medical professional based on a specific heart rate. So in the client application that the user or patient is going to use in this case, we're going to predefine a notification threshold. So for example, we can say if the heart rate exceeds, let's say, 85 beats per minute, I want to send a push notification automatically to the doctor. And we're going to show you how to do that and how to also send a message that includes the user's user ID as well as their current heart rate as part of the push notification. So here you see some screenshots of the consumer application that we're going to create. On the left, you see the native iOS 8 style, and on the right, the two screenshots on the right show a custom iOS style. We provide built-in support for native UI styling across iOS, Android, Windows, and Mac, as well as custom UI styling. Now, the components that we're going to use on the BaaS side for our consumer application consist of a provider component, as well as backend storage. Backend storage will be used to actually store our heart rate, our current heart rate data, as it's being retrieved from our Bluetooth LE smart device. BackendQuery will be used to then query the existing data and display it in our BPM history log as well as our chart. Backend users, the Backend users component, will be used to log in our user. And then Backend push will be used to notify the medical professional that a specific user's heart rate has exceeded the preset threshold. Other components that we'll be using include, of course, our Bluetooth LE component, our stylebook component for changing the UI style of our application, a timer component for automatically updating our chart every second as new heart rate data is retrieved, several data components such as our memtable component and REST response dataset adapter component, a charting component for showing data in a chart, list view component that of course shows our BPM history and also our current heart rate data, a tab control so the user can tab between measuring the heart rate, looking at the heart rate history and settings, and various other UI components. The other application that we're going to build is a healthcare provider application, and it consists of a Kinvey provider component that is connected to our push events component, and it also consists of several UI components such as our toolbar component and label for displaying the application name, along with a list view and an image component. And this application is going to receive a push event from the other application if a user's heart rate exceeds a certain preset threshold, and then we'll display that notification in our list view component. So now let's get started with our demos. So let's have a look at our demo application. So our demo application consists of two different forms, a login form and then our heart rate form. And our login form is where the user logs in and then sets their BPM threshold. The doctor tells them, or their physical therapist, for example, or their personal trainer tells them to set. And then if the threshold, if your heart rate exceeds that preset threshold, we're going to send a push notification to the medical professional, letting them know the name of the user and the current heart rate that it's recording. You can choose from the built-in native styles for iOS, Android, Windows, or Mac. And you can also create your own custom styles as well if you want to fully skin your application to have an entirely different look. And I'm going to show you how to change the look of your application. And we work with style files that you can apply to each of your views. So for example, on an iOS view, you would just place a stylebook onto your form. And then after you've placed the stylebook onto your form, you load the style to it and then change the stylebook property on the form to the stylebook that you had placed onto your form. And that then allows you to take the custom UI theme and apply that to your particular form or particular view. If you're working with several different views, you're going to want to load the appropriate style for each of the views and each of the target platforms. So for example, to target iOS 7 and 8, you're going to want to include 1x, 2x, and 3x resolutions. To target iPhone 4, 5, and then the new iPhone 6 devices. And on Android, you're going to want to include 1x, 1.5x, 2x, and 3x resolutions. On Windows, you can generally include a 1x resolution, and on Mac, you should include a 1x and 2x resolution, so you can target both the standard Macs as well as Retina devices. By default, we have built-in support on all the platforms for all the different resolutions I just mentioned, and they're all included as part of the native styles for each of the target platforms. So login form, our login form consists of a tab control with 2 tabs. We have a tab for logging in the user, and then we have a second tab for setting the threshold. Now the tab control position property has been set to none, which allows me to use the tabs as views, so to speak. But of course, you could also switch between top, bottom, dots, etc. However, in this case, I want to make the user log in first, and then after the user has logged in, I'm going to transition them to the threshold tab. And after the user sets a threshold, we're going to close the login form and then bring up our heart rate form. The tab consists of a top-aligned image, and this is our logo for application. And then we also have a list box we're using as a container, so to speak, to include 2 edit controls, our username edit and our password edit. Then we also have a button for logging in. And this is edit 1 and edit 2, and we just renamed them to username and password for the edit controls. Now let's navigate to our threshold tab, and you can navigate using the active tab field here or by clicking on the dots below. Then we also have a list here that contains an edit control or a number box and a button. And what the number box allows the user to do is set a threshold, and if you look at the keyboard option, it's set to number pad by default. So that means if the user taps on the number pad or number box, T-number box component, it will automatically bring up a numerical keyboard for the user to enter the BPM notification threshold. And then we have an event set up for setting that threshold. Now, for our BaaS enabling of our application, we have our T-Kinvey provider component, we have a T-Backend storage component, and a T-Backend users component. So the Backend users component is connected to our Kinvey provider component, and the same is also true for our T-Backend storage component. On our Kinvey provider component, we have set our app key, our app secret, a master secret, and have also defined a username and password. In this particular case, the username and password is the one that will be the same one that is assigned to the application that will receive the notification, which in this case is our admin, for our medical professional to receive a notification if the BPM exceeds a certain threshold. Then I also have an Android push GCM app ID, and that is our Google Cloud Messaging ID. In order to receive push notifications, you will have to go to Google's site and sign up for a developer account, and in there register an app for in order to receive a GCM app ID. And that's something that you will also then have to link with your Kinvey account for receiving a push notification. Now let's have a look at our code. And for that, I'm going to navigate back to my login tab. So here our code, what we're doing is on-click for the button. We're using the on-click event. And then we are setting a variable for T-Backend entity value. And we're logging in the user with the username property and the username text and password text fields. So in this case, it's just 2 different edit controls that I have on my form. One I renamed to username, one I renamed to password. I'm passing 2 strings, a username and a password. And then I'm going to log the user in if the logging in process was completed successfully. If it wasn't, and Kinvey does not recognize that username or password, it will automatically put back an error message saying that you need to re-enter your password. After that part was successful, I then navigate the user to the threshold tab. Also have an on-form create event, and that event is to automatically set the login tab to active. What that means is when the application first comes up, the first screen that is shown to the user is the login tab. Now let's have a look at our second tab. That is our threshold tab. On this tab, we're defining the BPM threshold. Let's have a look at the code here. So here we are creating a new JSON object, and we're adding two JSON pairs. One for the threshold, which takes the value of our BPM notify component, and that's actually our T number box component. It takes that value, and then it takes the username that you used to log in to the application. And we're going to create a new JSON object here that contains both of those JSON pairs and then creates a data collection on our BaaS backend using Kinvey. And so it's going to create a data collection called heart rate user data. And it's going to create two columns, one called threshold and the other column called username. And it's going to store the threshold value that you've entered into the number box component and the username that you used to log in to associate those two. After that has been done successfully, it's going to show a message saying that the threshold has been set. At that point, I'm going to hide my form and bring up my heart rate monitor form. Now let's have a look at our heart rate monitor form. And this form is the main application, and it consists of our Kinvey provider component again. The same properties are set as I had on my login form. I also have a backend storage component for storing all the new heart rate data that I'm receiving from my heart rate monitor. I have a BackendQuery component, and what that BackendQuery component does is it looks in my Kinvey backend using the heart rate cloud data collection, which I'm going to create when I scan for my heart rate. As soon as I scan for the heart rate and has detected the heart rate, I'm going to write a new data collection, and it's going to be called Heart Rate Cloud. And I'm going to store my current heart rate, the time that's recorded, the date, etc., associated with that heart rate in my data collection. The BackendQuery component is then able to retrieve that data that I've stored in the cloud. And what I'm going to do with that is on the History tab, I'm going to have a list view that is bound into that BackendQuery component to display my historical data. And if I go here to my View Live Bindings Designer and zoom in, you will see that I have visually bound my list view here to my BPM log and time. And those are the two JSON pairs I'm going to create, a BPM log, and that's my current heart rate, and the time at which they were recorded. Both of those values have been bound into my list view component, and that will display the recorded time. And then on the detail side, which is the bottom aligned text in this case, on my list view, I'm going to also display the associated time. And then, of course, I also have a chart here, and the chart I'm populating with the recorded data as well. I also have a settings tab. On the settings tab, I'm displaying my Bluetooth heart rate monitor information, the name of my heart rate monitor, the body location, whether the user is wearing the heart rate monitor, and the contact status, whether it's connected or not connected. So let's have a look at our Bluetooth LE component. And if I switch over to the code, the first thing we had to do is define some UUIDs. So from the Bluetooth website, we were able to get the service, on the service viewer tab on the Bluetooth website, we were able to get the Bluetooth UUID for the heart rate service. And that service exposes the heart rate and other data from your heart rate sensor. And that heart rate sensor is using one of these standard Bluetooth GATT profiles. And then we had to get the heart rate measurement characteristic and also the body sensor location where the user is actually wearing the sensor. And that is a Bluetooth characteristic, and we had to get the UUID from the Bluetooth website, and those are defined right here. So you see from the Bluetooth website, we got the Bluetooth UUIDs for both of those. And then we also have an array here where we're using the body sensor location characteristic to index the array to display the string that then tells us where the user is actually wearing the heart rate sensor. Now, once we've successfully read our Bluetooth data, then we're going to be able to display on the memo the UUID information that we're receiving. Now, of course, we also have our scan event, and if you look at the code for that, let's go back to the measure tab here. We have an on-click event, and then we call the doScan method. You see that we are automatically clearing the heart rate text as we're calling Bluetooth Discover devices, And for several seconds, we're searching for available heart rate monitors that fit our UUID that match the Bluetooth GATT profile. Now, once we've done that, we added a new method here called save in background, and that uses threading in order to execute and store to the continuous heart rate data in the cloud while you're actually processing the data. And so in this case, we're using actually a parallel programming and threading in order to, in the background, store the data as it's being retrieved. So we're using multiple threads in order to be able to continue to use the UI and then store the data in the background. So here we created several variables. We're recording our heart rate with a time, and then our current time is, we're adding several JSON pairs. One is for a BPM log, and that's the current heart rate. Another one is for the current time. And the third one is for the username, and that's the username that we're getting from our login form. We're going to create several new JSON pairs. We're going to create a new data collection called Heart Rate Cloud that's going to include 3 columns, a BPM log for the current heart rate, a time log, and a username. And then we're also going to display the current heart rate on a label and add the heart rate data to a list view. And if you look at the code here, we're going to display and add to our list view the heart rate data as it's being recorded, plus the current time. And the current time we defined here for format date time. And that allows us to display the current date and the current time, plus the current heart rate in our list. Then, of course, we're calling our save in background method to store the new heart rate data. And if our heart rate data, and that is the data here shown on our label that's displayed on top of a heart rate graphic, if that data is higher, if that number is higher than the predefined threshold, then we're going to send a backend push. And that is done by putting the backend push component onto the form and connecting it to a Kinvey provider component. On the Kinvey provider component, we've also defined a push endpoint, and that is to use business logic that lives in the cloud on the Kinvey side to execute some JavaScript that also lives on the Kinvey BaaS backend in order to be able to send that push notification once the heart rate exceeds the predefined threshold. It's basically a push trigger that we're able to execute anytime your current heart rate is higher than the predefined heart rate. We also have a timer, and so what we're doing here is we have an on-timer event. And it says if the current tab is our history tab, then we're going to update the graph per every second. And that allows us to show continuous data on our graph on our history tab as we're actually retrieving the data from the heart rate monitor. Now let's have a look at our TREST response dataset adapter that's bound into an FDMem table. And our FDMem table is connected to our REST response dataset adapter. And if we look at the properties here, we are using the FDMem table as a dataset and the response JSON from the BackendQuery. We're then storing the data we're getting from the cloud in our FDMem table, and we're able to bind it to, for example, our list view to display the data right from the cloud in our historical data list view. Now let's have a look at our BaaS account. So here I've predefined 2 new data collections. One is called Heart Rate Cloud and one is called Heart Rate User Data. These will also automatically get created for you as you're running the application if you don't predefine them. So you see they currently don't have any columns except the default columns that are automatically created. So with our IDE, we provide the Fire UI multi-device paradigm, and that allows you to design your application, code your application on the master view. Then each created view inherits all that code, and you can make custom changes for a particular view that you want to have executed at runtime. So for example, if you want the application to do something slightly different on iPhone and Android, you could create an Android view and an iPhone view, and then you can customize the UI and code as needed. So here in this case, I have my iPhone view, and I can tweak, for example, the size of the logo, etc., to customize how that application appears on my target device. So now I'm going to deploy this application to my iPod Touch. Now here you see the app running on my iPod Touch, and I'm using a mirroring app to display the actual app running on my physical device. So I'm going to add a user here first via my Kinvey account. I'm going to click Create User, and I'm going to use that username to log in into my application. And now it's going to tell me that I'm logged in. And then I'm going to set my threshold, say to 89. So I want to send a heart rate notification anytime my heart rate exceeds 89 beats per minute. So now I'm navigated to my main application. And if we go over here and look at heart rate user data, you will see that I've created 2 new columns in my data collection. And one is with my username, and then it's my associated threshold. Now, before we start scanning for the available Bluetooth devices that we can connect to and the heart rate monitors we can connect to, I'm going to go back to the IDE here, and I'm going to select my remote push application, and that is my heart rate cloud admin application. That's designed for the medical professional. And I'll show you the code here in order to be able to send a push notification to the medical professional once the heart rate exceeds a certain threshold. So let's have a look at our Heart Rate Cloud Admin application. This application allows you to receive push notifications as the admin if a particular patient's or user's heart rate exceeds the predefined threshold that we set in their application. So we have 2 components. We have our Kinvey Provider component, again, has the Google Cloud Messaging App ID set, has our app key set, our app secret set, master secret set, has our password, username password set to admin. We also have our push endpoint set to my message, and that's something that we defined right inside our BaaS interface that I'm going to show you shortly. And then we have an event set up. So on our T-push events component that I've linked to my Kinvey Provider component, we've defined an event that's called onPushReceived. And on push received, we're going to add text to our list view items. And the list view item is going to show the name of the user plus their current heart rate. And then we're going to send a notification to the medical professional. So now I'm going to deploy this application to my Nexus 10 device. So on the right here, you see my iOS application running on my iPod Touch that I'm mirroring to my MacBook. And next to it, you see my Android application that's running on my Nexus 10. The Android application you're seeing is my Heart Rate Cloud Admin application, and that is the application designed for the medical professional, for example, or a personal trainer. And this demo allows you to send a push notification to that application once the heart rate exceeds the predefined threshold. And in my case, I had set that to 89 beats per minute. So if the heart rate exceeds 89 beats per minute, you will receive a notification in the Heart Rate Cloud Admin application. So now I'm going to connect to my Zephyr heart rate monitor. So here you see it's adding my heart rate to my list. And I'm going to run to bring up my heart rate. And so here you see the notification on my screen, and I've received a push notification in my application. Now, if I close that application, I will get the notifications, and they will be coming in through my Android Notification Center. And you can see them right here. Now I'm going to stop scanning my heart rate. And if I click on the History tab, you can see a chart with my BPM history. And you can also see that I'm displaying a nice little heart rate icon to the left of each recorded historical heart rate, and along with the date and time. So here you can see the heart rate name, the sensor location, and that I made contact via the sensor to my heart rate monitor. You will see that my heart rate is recorded here with a timestamp, and it's recorded against my username. And the heart rate user data also displays my username and my threshold that I've set. Now, if we go to business logic and we go to my message, that is my custom endpoint that I set on my Kinvey Provider component. And that is some JavaScript that gets called when I want to send a push notification when the heart rate exceeds the predefined threshold. And that's going to send a push via the Backend as a service server. So it triggers a push, and then it sends a message to the medical application. And then users, of course, I have my users defined. I have a variety of different test users, and then, of course, my Sarina webinar user. And to add a user, you just click on Add User. You set the user's username and password, and then that's the username and password that they're going to log into from your application. Alternately, you could also add functionality to actually register a user right from within the application if you didn't want to predefine it from the beginning. Now let's open it up for some questions.
So the question is about building Bluetooth apps without using GATT, and what's involved in that.
I think you did a demo on that before with something that was Bluetooth, didn't you? Or am I recalling that incorrectly?
I think David I did. I don't remember.
I think David I did. When you guys did the gadgets webinar in the past.
Oh yeah, we did. That's right. We did the car, the
Bluetooth car. That's right.
The Bluetooth car. So you can get to the without GATT support. You can still access other devices, but it's a lot harder if you don't have GATT support. GATT basically defines some of the way the interfaces work. So you can do it without GATT, but it's just more work. So somebody has to figure out the interface for it. How do we find the UUID for a heart rate monitor? I have both the Timex and Garmin straps, 2 of each.
That depends. In the case of my example, I was using the Zephyr heart rate monitor. I've also tried the same demo with the Polar H7 heart rate monitor. Both of those use a standard GATT profile, and on the Bluetooth.org website, you can actually get a bunch of that information as long as that manufacturer of the device uses those standard GATT profiles. There's actually a heart rate monitor service that you can access that's a standard GATT service. I don't know what those 2 devices that you were mentioning, I don't know if they are using the standard GATT profiles or not. I think the best way to do it would be to look online. Alternatively, you could also run that demo that we have an example that we ship with RATsuit XC7. It's not the exact demo you saw here because I've extended that demo to include BaaS support. But we have a heart rate demo, and that's included in the samples with RATsuit XC7. So if you go to samples, mobile samples, and you go to device, sensors, and services, Bluetooth, you can find a heart rate demo there. You can definitely deploy that and try connecting it to your heart rate sensor. Alternatively, you could do research online and see if that uses a standard GATT profile or not.
And we have that Bluetooth Explorer as well, right? That does will let you discover.
That's correct. We have a Bluetooth Explorer demo that's also in that same folder, and that demo has allows you to get a bunch of data back from your Bluetooth device, which you can then use in your application.
Yep. And I think there's actually an update on SourceForge for that. So if you just do a subversion update there, you can get some more updates to that Bluetooth Explorer. And there's actually other Bluetooth Explorer apps too, but you might as well download XC7, activate your trial, and then use the Bluetooth Explorer that comes with it.
That's right.
So are you going to make the source available for your demo?
Yes, I will be making the source available. It's on my list of things to do, and I'll blog about it once it's live. And I have demos for both Object Pascal and C++ for that same exact demo that you saw today.
How can I activate sounds for AP&S appends in the Kinvey demo?
Yes.
On iOS only?
So on iOS, there is a way to display or to make a sound as the notification comes in. There is some information on the Apple website that talks about how to do that. I believe you have to reference an MP3 file in your info plist. I'm not 100% sure, but there is information on the Apple website if you look it up on what properties you need to set to make a sound when a notification is received.
Are there other BaaS providers that can be connected to, and how different is the process?
Yes, we have support for also Parse and App42. The process is very similar. In regards to the IDE, what you saw today here, it would be the same. I have my backend component, I had the backend storage component, backend push. They can all be just connected to the provider component. So Kinvey provider, Kinvey provider is a BaaS provider component that you can connect to all of those other backend components that are available. The same is true if you're installing the App42 component pack or you're using the Parse provider component that's included. When it comes to the BaaS backend web interface, they're all different because each company has designed their own. So each of them have their own web interface that you have to make yourself familiar with. They all support JSON. So, for example, if you had a data collection that you stored in Kinvey, now you wanted to use it in Parse, for example, you could do that. You could export the JSON data and re-import it, and you would get the same column structure, etc. So it is very similar working with them across the board. I've used them all, and they are all very similar when you're working with your application. It's really, in this case, what you saw today here, it's really only the main difference is the BaaS web interface.
Do we always have to write JavaScript on Kinvey to push events?
No, you can. So that depends. So what you saw here today is I showed the backend push component. And the backend push component works with the tpush events component. And what you saw there was I was allowing one application, being the heart rate monitor application, to push a message to the client, the professional application or the medical application. So in this case, what you were seeing was sending a push notification from one app to another. David, I did a blog post and a video a while back, and I also blogged about this, and that was an example of using a desktop application to send a push message. So, for example, you could write a desktop client where you could send push messages to your mobile application users. This is the same concept as what you saw here, is we're using one application to push a message to another application. In that case, I was using tBackendPush, and I set up a custom endpoint. And the custom endpoint was allowing me to push a message from my one application to another application. If you're using the BaaS web interface and you just want to send a push notification to your users from within the BaaS web interface, then you don't need to set up a custom endpoint. You can just use the tpush events component. You go to your project options, make sure you have push notifications enabled. Then that will write the correct Android manifest file settings that you need to set if you're deploying the application to Android so that you can receive the push notifications. And with the tpush event component, you will then receive those notifications in your application. Of course, for Android, you need to set your Google Cloud Messaging ID. That's a GCM ID that's set on your provider component. So, for example, Kinvey provider component has a GCM ID property. You would have to go to the Google site and you sign up for an account, and it will, when you create a new project on a Google site, it will give you that ID. And you also have to add that ID in your Kinvey account or BaaS provider account. In that case, if you just want to send notifications to an application, you can do that all within the BaaS web interface. In this case, because I wanted to be able to send a notification from the medical, the patient's application to the medical professional's application, and I was sending a push from one app to the other. If the heart rate was exceeding the predefined threshold, I was using that custom endpoint. That is not necessary if you're just sending a push to an application, and you can do that directly via the BaaS web interface.
Robert pointed out that Kinvey is probably not HIPAA compliant, and so for actual medical app, that might be an issue. Do you know anything about that?
I don't know anything specifically about that, but I do know that they encrypt all the data that's being sent back and forth, and that's being stored in the cloud. And they do have a security document. So they have a white paper on this topic, and it's at kinvey.com/security-overview. And it's a great white paper that talks about data security in the cloud and what Kinvey has done. And again, it's kinvey.com/security-overview.
This demo assumes the use of Kinvey. Is there a demo showing how to create a disconnected model that syncs with its own backend?
This demo was something I created in conjunction with Kinvey in regards to focusing on using backend as a service. Alternately, you could, of course, store the data in a local database as well. You could store it in your own, in your own database. You could store it within the app. You could store it in a local database within the app or remote database. But this particular example was designed to show cloud. It doesn't mean it couldn't be changed, and we'll make the source code available, but this demo does not have that functionality.
What's the cost associated with Kinvey, using Kinvey?
They have various plans, and it's best to go to kinvey.com and look at their pricing. I do believe they have a free plan. They have like an indie plan, a business plan, and an enterprise plan, if I'm correct. And you can go to kinvey.com/pricing. You'll see they have a starter free plan, indie plan, business, and enterprise plan. So they have different pricing models depending on the company and the features that are available.
So the app talks to the Bluetooth device using its unique ID. Is that unique ID on the device somewhere?
Yeah, that's the UUID that you can get for the particular device. Yes.
And so that's unique to the device. So you get that when you talk to the device, you find out what the UUID is.
Yes, usually the device manufacturers have unique IDs that they provide, and if you use that Bluetooth Explorer demo, you can get that information back.
So that's a way, if you have multiple heart rate monitors, you could distinguish between
Yes,
them.
there is a manufacturer-specific one. So, for example, if you had 3 people that all were using heart rate monitors that use the standard gap profiles, you could allow the user to sync, or you could connect to a specific heart rate monitor by using the UUID, and then you could show a selector via a combo box, for example.
Is standard Bluetooth supported as well as Bluetooth LE Smart?
We have support for Bluetooth Classic through our tethering implementation, and then Bluetooth LE through the Bluetooth LE component.
I know on iOS you have to have a special license from Apple to do
Yeah,
Bluetooth
iOS
Classic.
for Bluetooth Classic, you have to be part of their, I think it's the MFI program. It's for device manufacturers.
What about a demo for Azure push notifications?
Yeah, that's a good suggestion. We, today we have support for Kinvey Parse and App42 for push notifications out of the box with BaaS. But that is something that we could look at demoing in the future.
How does Kinvey know which device to send the notification to?
So when you're sending a notification, you define who you want to send a notification to. You can send a notification to all users. You can send a notification to a single user. You can create something called groups or channels, where you send notifications just to a specific group of people. So for example, let's say you're building an application that's a food-based application, and you want to display offers for Italian food or French food in your restaurants in your area. Users could subscribe and say, I'm interested in getting offers about Italian food or French food or German food, etc. And they would subscribe to that, and when they sign up, they could say they're interested in that, and then you can send a push notification to that group of users. You can actually define that in the BaaS web interface. Even if you're sending that notification right through the BaaS web interface, you can define what users to send that to.
So you basically create like a JSON query against their user record.
Yes, and you have, and there is an example on my blog. So if you go to blogs.embarcadero.com/Sarina Dupont, and at top left side, right on my blog, I have a kind of a sticky link talks about BaaS tutorials, and I've highlighted many of the different features you've seen here. Everything from signing up a user to sending a password reset email to how to send notifications to a specific user, etc. And it's all available as tutorials on my blog.
All right. Well, thank you so much, everybody, for joining us.
Thank you. Bye.